The sun is not burning. It is doing something far more violent. Every second, deep inside it, matter is being crushed, fused, and transformed into energy. And that energy becomes the light that touches your skin. From Earth, the sun looks simple, warm, bright, familiar, a golden circle rising every morning. But up close, it becomes something else entirely, a moving ocean of plasma, a magnetic engine. A star filled with pressure, radiation, invisible storms, and forces strong enough to shape life on Earth from 93 million miles away. For centuries, we could only watch it from a distance. Then NASA decided to go closer than any spacecraft had ever gone before. That mission was Parker's solar probe. It did not land on the sun, nothing could, but it flew into the sun's outer atmosphere, the corona, where it sampled particles, magnetic fields, and solar wind directly. In a way, NASA touched the sun, and what it found made the sun even stranger. The first mystery is the corona itself. The visible surface of the sun is called the photosphere. It is already unimaginably hot. But above it, the corona is even hotter. That should feel impossible. Usually, the farther you move away from a heat source, the cooler things become. But around the sun, the outer atmosphere can reach temperatures far higher than the surface below it. This is one of the great solar mysteries. And Parker's solar probe was sent straight into that mystery. As it moved closer, it entered a region filled with violent particles and twisted magnetic fields. The sun was not smooth. It was not calm. It was not just releasing a steady stream of energy. It was snapping, bending, and throwing magnetic structures through space. One of the most surprising discoveries was something called magnetic switchbacks. These are sudden bends in the sun's magnetic field. Almost like the field lines briefly whip backward, then snap forward again. Scientists had seen hints of them before, but Parker found them much closer to the sun and in much greater detail. This matters because magnetic fields control the sun's behavior. They help shape solar wind. They help trigger eruptions. They help launch charged particles across the solar system. And sometimes, they send those particles toward Earth. That is when the sun stops feeling distant. Solar storms can disturb satellites, damage communications, affect GPS, threaten astronauts, and in extreme cases, even stress power grids on the ground. So NASA does not study the sun only because it is beautiful. NASA studies it because the sun can reach us. But the deeper mystery is not only above the surface, it is beneath it. The sun is mostly hydrogen and helium. It is not fire like wood burning on Earth. Fire needs oxygen. The sun is powered by nuclear fusion. And that fusion begins in the core. The core is the heart of the sun. There, gravity squeezes matter under extreme pressure. Hydrogen atoms are forced together so violently that they fuse into helium. In that process, a tiny amount of mass becomes energy. That energy is the reason Earth has daylight. But it does not escape quickly. A photon of light born in the core does not fly straight out. It begins a long, chaotic journey. It is absorbed, released, absorbed again, redirected again and again through the dense interior. The light that reaches Earth in about 8 minutes may have spent thousands of years trying to escape the sun itself. That means the sunlight outside your window began its journey long before you were alive. Maybe before entire civilizations rose and disappeared. After leaving the core, energy enters the radiative zone. This region is thick, dense, and slow. Then comes the convection zone. Here, the sun begins to behave like a boiling ocean. Hot plasma rises. Cooler plasma sinks. Massive currents move energy toward the surface. These motions help create the churning patterns we see on the sun. They also connect to the magnetic forces that twist and break above it. So what NASA found is not a simple star. It found a layered machine, a core where matter becomes energy, a radiative zone where light gets trapped for ages, a convection zone where plasma rises and falls, a surface that glows with released energy, and a corona above it all, hotter than expected and shaped by violent magnetism. The sun is not still. It is restless. It rotates. It erupts. It breathes out solar wind. It throws storms into space. It builds magnetic tension, then releases it in explosions that can stretch across millions of miles. And Earth lives inside its influence every day. We depend on the sun. But we are also vulnerable to it. One powerful solar eruption aimed at Earth could remind us that our technology exists under a star that never stops moving. That is why Parker's solar probe matters. It is not just exploring the sun, it is helping us understand the force that controls the space around our planet. The sun gives us light, heat, weather, seasons, life, but it also gives us radiation, storms, and danger. From Earth, it looks steady, almost peaceful. But NASA found that our star is not peaceful at all. It is a violent, layered, magnetic world of plasma and pressure, a place where matter becomes light, where invisible fields twist through space, where energy born deep inside can take thousands of years to escape. The sun is not just above us, it is connected to us. Every sunrise is the end of a journey that began in the heart of a star. And the more NASA looks inside that star, the clearer one thing becomes. The sun does not only make life possible, it reminds us how fragile life really is.